Hello? Hello, is it audible? Are you people there present in the class? Chetan?
Yes, ma'am, audible.
Okay. So, in the previous class, we were discussing about the sequence impedance of the various components, isn't it? Generator, isn't it? Then we have also learned about how to represent the PSN, NSN and ZSN network for the generator, isn't it? Even for the transmission line also. So in today's class, let us discuss about how to represent the sequence impedance network for a three-phase transformer. Okay, we have started the discussion actually in the previous class, but due to shortage of time, we couldn't complete the discussion there. So in today's, let us discuss the sequence impedance network for a three-phase transformer. Okay, so as we all know, that is transformer is a static device. Okay, and hence it does not have anything like a phase sequence. So therefore, the positive sequence impedance is equals to the negative sequence impedance. Okay, and these two will be equals to the leakage reactance X. Okay, and these two will be equal to what? The leakage reactance XL. So that is positive sequence impedance and negative sequence impedance will be equals to XL. Now what are the networks for this PSN and NSN for the three-phase transformer? I gave you in the previous class itself. Okay, so this is the reference what we have. So this is Z1 impedance and the current sequence is taken as a positive sequence current as I. So this represents positive sequence network of the three-phase transformer. Now, what will be the negative sequence network for the three-phase transformer is? So it is almost same. Here Z2 equals to Z1. Okay, and the current going into this let us take it as I. And this represents negative sequence network of the three-phase transformer. Now, what will be the zero sequence network of a three-phase transformer? That we need to discuss. So that depends on the various conditions there. So in what way the primary and the secondary configurations are connected. So whether it is a star, delta star, or a star with the neutral grounded, or star with the neutral isolated, all these concepts, all these aspects we need to consider in order to write the network. Okay, so let us see how to write the zero sequence network for a three-phase transformer for various configurations. Okay. So first you note down this diagram there. Later we will go ahead with the next. That is how to represent the zero sequence network for the various configurations. Here it is audible, sorry, visible there board. Is it visible?
Yes, ma'am, visible.
Okay. So now let us study, okay, the various configurations for the three-phase transformer. So first item the procedure. Had I given you the procedure steps in the previous class or no? Have I dictated the procedures for writing the ZSN network for a three-phase transformer in the previous class?
No, ma'am.
No. Okay. Take down procedure to draw ZSN as a zero sequence network of a three-phase transformer. Okay. So first take out the general circuit for any configuration. First take out it is general circuit for any configuration. So we have totally 4 switches here, A, B, C, D. Okay. Take this as Z naught. At least okay, have you finished noting the diagram?
No, ma'am, still noting.
Have you finished noting down the diagram?
No, ma'am.
Okay. Respond there. Have you finished noting down the diagram?
No, ma'am.
Yeah, okay. So you can see here we have totally 4 switches. Okay, A, B, C, D. So A and B are series switches, C and D are parallel switches here. Now when these switches has to be closed and when the switches has to be kept open. So let us understand the concept. Okay, here if you just have the basic transformer. So we have primary and secondary side, isn't it? So if the type of a configuration on the primary side is star with the neutral, is it visible the board there?
Visible, ma'am.
Yeah. On the primary side, remember carefully there, on the primary side, if the configuration type of configuration is with star, with the neutral, grounded, okay, not with the reactor, if it is grounded with the reactor or directly grounded, whatever it is, but if the neutral should be grounded. Okay, if the neutral is grounded, then the switch A has to be closed. Okay, the switch A has to be closed. When the switch A has to be closed then, when the star connection with the neutral grounded via the reactor or without the reactor, in such circumstances you are supposed to close the switch A. If the case is not like this, if it is only star connected, okay, if it is only star connected, then you should not close the switch A. It has to be kept open. Understood that? Then, suppose if the primary side is not star connected, suppose if it is a delta connected. Suppose if it is a delta connected, then rather than closing the switch A, you are supposed to close the switch C. Okay, if it is a delta connected, you are supposed to close the switch C on the primary side, not the switch A. Understood? Next, coming to the secondary side. Okay, coming to the secondary side, suppose the configuration type of configuration on the secondary side is only star connected. Then either of the switches should be closed. Both B and D should be kept open. Same as that of primary side. Suppose if it was star connected on the primary side also, none of the switches were kept closed. All were open. So on the secondary side also, when this is the type of connection that neither the B nor the D should be closed. Both should be kept open. Suppose if the type of connection is star with the neutral grounded, okay, then which switch has to be closed here? The B switch. Okay, the switch B has to be closed. Okay, suppose if the type of connection on the secondary side is not this, if it is a delta connected, then the switch B has to be closed, keeping the switch B open. Hope you might have followed the concept there. So just remember, on either sides, if the type of connection is star with a neutral grounded, so then only the series switches has to be closed. That is A or B has to be closed, irrespective of whether it is primary or secondary. If the configuration given is star with a neutral grounded, only then you are supposed to close the series switches. Suppose if it is a delta connected, then you have to close the parallel switches, C or D. Okay. So this is what you need to remember there. So with this, we will try to write the zero sequence network of various configuration. Then we will go for solving an example on this particular concept. Okay. So now first note down the procedure there. Then after noting down the procedure, we will go ahead with the examples for various configuration. Okay. So take down the first step there. Take down first point. Close switch A. Write down close switch A. Close switch A. If the primary is star connected, with neutral grounded. With neutral grounded. Next, second point. Close switch C. Close switch C. If the primary winding is delta connected. Close switch C. If the primary winding is delta connected. Keep both switches. Keep both switches A and C open. Keep both switches A and C open. If primary winding is only star connected, with neutral isolated or ungrounded. With neutral isolated or ungrounded. Take down next point there. Next point. Close switch B. Close switch B. Close switch B. If the secondary is star connected. The secondary is star connected. With neutral grounded. With neutral grounded. Full stop. Okay, now keep both switches B and D. Keep both switches B and D open. If secondary winding is star connected, with neutral isolated. Take down the last step. Close the switch D. Close switch D. If the secondary is delta connected. One more point, last point. Take down one more point. Switches need not to be shown in the final network. Switches need not to be shown in the final network. So with this procedure, now let us try to write the zero sequence network for various configuration of the three-phase transformer. Okay. So make 3 columns there. Okay. Make 3 columns. So in the first column, give the heading there configuration. Next, give the heading as binding connection. And lastly, zero sequence network. Okay. So now let us see for the configuration star delta how to write the zero sequence network. Okay, so for this configuration, let us take the configuration as star delta, and here binding connection is like this. So primary side is star, secondary side is delta. Okay, so what will be the zero sequence network? Observe here, later you can note it down. Concentrate on the board there. So primary side is star connected. So first write the basic general circuit of a three-phase transformer. What is the basic circuit we have is? It has 4 switches. So write the circuit as it is first. Okay, this is A, this is B, and this is C. Now concentrate on the primary side. Okay, the winding connection. So what type of a connection here present on the primary side? It is a star connected. So star connected means star connected with neutral isolated. This is the type of configuration what they have given on the primary side. If that is the case, just refer the procedure what I just dictated now. So what to be done if that is the case there? Which switch has to be kept open or which switch has to be kept closed there on the primary side with the star connection? Yes, with star connection, which switches has to be kept open and which switches has to be kept closed. So which two switches has to be operated on the primary side in order to close or open them? At least tell me that. That is A and C for primary side. B and D is for the secondary side. If it is a star connection with neutral isolated, this is the type of connection given in the configuration. Neither, okay, any of the switches need not to be closed. Okay, none of the switches has to be closed here. So both the switches A and C should be kept open. Okay, so because the type of connection given is star with the neutral isolated. So coming on the delta secondary side, what is the type of configuration given there? Delta connected. So delta connected means which switch has to be closed here? This switch. Okay, so what is the last step he says in the procedure is you can. Okay, switches need not to be included, means like this symbols need to be neglected in the final circuit of the zero sequence network. So how can I write down the circuit is like this. So we have Z0, this is Z0 actually. Okay, so I'm not including the switches here on the primary side. Okay, it is open there. So let me not include at all this switch there. This is what we have a reference bus. Which switch is closed there? D switch, okay, is closed. So, represent by short circuit. So, this is the final ZSL network for the given configuration. So, like that, let us try to write the final ZSL network for various configurations. So, that was for the star delta. Okay, that was for the star delta. Now, let us learn to the other configurations. So, let us take the next configuration as star with a neutral solidly grounded on the primary, on secondary it is delta connected. So what is the winding connection? This is the winding connection there. Then what will be the network there? First get the general circuit I told you, the procedure. Okay, this is the general circuit, this is Z1. So now since on the primary, what type of configuration you have? Star with a neutral solidly grounded. Which switch has to be closed here? The switch A. Okay. So this has to be removed actually. And the secondary side, delta connected means switch D has to be closed. Okay, this has to be kept open. B has to be kept open. So what is the final network you can write there? So this is switch A, shorted. We have Z0. Then this need not be included as it is open circuited. On the secondary side, B is closed. So it is shorted. So this is what we have. Final ZSL network for the configuration. Star with the neutral grounded on the primary and delta connected on the secondary. Okay, note down this. Later we will discuss for the other configurations as well. First note down this. Inform once you finish noting down. Have you finished? Okay, if you are finished, okay, try this for the configuration what I gave now. Try for next configuration, that is star on the primary, star with the neutral isolated, on secondary star with the neutral grounded. Try for this on your own. One more, primary and secondary delta connected. Primary and secondary delta connected. So try for these two configuration on your own. So what difficulty you face, you can pose a question there. Shall I keep your fingers noting this? Have you finished noting ZSC network? Yes, Noor Mohammed. Noor Mohammed. Yes, anybody respond there? Have you finished noting down the diagram there?
Completed, ma'am.
Okay. Now try this. How to write the zero sequence network for the given configuration there? Try on your own. Try to draw that. So this is the actual general circuit what I have written there. So how to modify the general circuit into the configuration given to write the zero sequence network? Try that. So what is the configuration given in the third? Star connected with a neutral isolated on the primary. On the secondary, star with a neutral solidly grounded. So which switches has to be closed and kept open on the primary? Observe that. On the secondary, what to be done? We just go through them. Okay, tell me for the configuration, primary side, A or C, which switches has to be kept open and which switches has to be kept closed here? What is the type of connection given there? Star with a neutral, ungrounded, isn't it? Tell me, ma, what to be done this side, primary side? Have you followed the concept or no? What you people are doing there? No response at all. Huh? Should I specify a written name? Voluntarily you can respond, no? Is Komaldani, are you there in the class? Chetan, you only respond. What you have done? Which switches you have kept open?
A should be
Chetan?
kept open. A should be kept open.
A?
A should be kept open.
Both the switches should be kept open. A and C both. Isn't it? Because the type of connection given is only star with the neutral isolated. So both the switches A and C should be kept open on the primary side. On the secondary side, what is the type of connection given is star with the neutral solidly grounded. If that is the case, which switch has to be kept closed here? B switch, C switch, and D has to be kept open. Then what is the final zero sequence network you are supposed to write? In the final zero sequence network, whichever the switches are open, you can need not to include those switches. So what we can do is, what is the network final network which we getting here is, so this is the reference. So none of the, neither C nor D is closed. Okay, so we have removed them completely. And this is Z. Now last configuration, next configuration what I have given, delta delta. Delta primary side is also delta connected or secondary side is also delta connected. Then which switches has to be kept closed here is C on the primary side and D on the secondary side. So what will be the resultant network here is? So this is the resultant zero sequence network for the delta delta configuration. This is Z. Okay. So if you have not written, note down that. So now let us see for the next configuration, that is delta on the primary and star with the neutral grounded via the reactor. Okay, observe here. Now you can see in the configuration, what he has given, primary side is delta, secondary side is star, with the neutral grounded via the reactor. So whenever you get this type of a connection, it is star with a neutral grounded via the reactor. So on which side you have that type of connection, either on secondary or primary, observe carefully. Then you are supposed to include in the general circuit not only Z0, okay, not only the Z0, but also the neutral impedance also should be included because neutral is grounded via the reactor. So as it is a three-phase transformer, 3Zn has to be included in the general circuit. So this is Z0. Since it is on the secondary side, I am writing the 3Zn on the secondary side. 3Zn. Now where will be the switch here? Okay, this will become the general circuit. Are you able to follow now? Okay. So this is the general circle. Now observe on the primary side, which is the rate of connection given delta. So I will be closing this switch. C. On the secondary is the star with the neutral grounded. This switch has to be closed here. Switch B. Then what will be the resultant network? Here. This is on the primary side. On the secondary side. So before the switch you have 3Zn. Then switch B is closed, then C is kept, that is D is kept open. So I have removed the switch. So this is the resultant zero sequence network for the given configuration delta star neutral grounded via the reactor. Okay. So next configuration. Okay, what is the next configuration given? On the primary side it is star grounded via the neutral via the reactor. That is on the primary side. On the secondary side is also star connected with the neutral solidly grounded. Okay. So let us concentrate on the primary first. Let the first write the general circuit on this. Okay. So you one of the given configuration is including reactor on the primary side. So primary side means primary side we need to include Zn. On the secondary side let us have the Zn. Total will give you the total impedance of the transformer. Okay. So now this is the basic circuit. Now since it is a star with a neutral grounded via the reactor, which switch has to be kept closed? Switch A. Okay. On the secondary again it is a star with a neutral solidly grounded. So switch B will be closed. Okay. So what is the final network there? What is final network we will have? So this is 3Zn, Z0, 3Zn, this is Z0. Then parallel switches I am removing that as it is not closed. This is final network for the given configuration. So note down that. So inform me once you finish noting that so that we can go ahead with the examples on this particular concept. Have you finished? it over, ma? Noting?
Completed.
Okay then. So take down our question there. Note down. A 250 MVA a 250 MVA, comma 11 kilovolts, 11 kilovolts, 3-phase generator, 3-phase generator is connected to a large system, is connected to a large system through a transformer, and a line as shown in figure. Note down the one line diagram here. Note down one line diagram. Later there is a continuation of the question statement. You just inform me once you finish noting down the one line diagram. Okay, continue the question there. Write down next para. The parameters on 250 MVA base. The parameters on 250 MVA base are as follows. Table generator ratings. X1 equals to X2 equals to 0.15 per unit, comma X0 equals to 0.1 per unit. Next, transformer rating. X1 equals to X2 equals to X0 equals to 0.12 per unit. Then, transmission line that X1 equals to X2 equals to 0.25 per unit. X0 equals to 0.75 per unit. So uniformly after noting down these ratings, and also you have equivalent system. Equivalent system maybe it has X1 equals to X2 equals to X0 equals to 0.15 per unit. Have you finished noting? Continue the question there. Draw the sequence network diagrams. For the system. Draw the sequence network diagrams for the system and indicate all per unit values. And indicate all per unit values. So go through the question there. Okay, we will solve the solution for this example in the next class. Okay. So I hope you might have received the assignment questions of PSA for the second internals there in the Google Classroom. Have you received the assignments related to power system
Okay.
analysis? Chetan, tell me, ma'am.
Ma'am, some questions you want to
Some questions were? I
you
didn't
want to
get
answer,
you.
ma'am.
Huh?
ಮ್ಯಾಮ್ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ನೀವೇ ಆನ್ಸರ್ ಬರ್ದಿದ್ರಲ್ಲ ಮ್ಯಾಮ್ ಅದಕ್ಕೆ
ಅದೇ
ಕೇಳಿ.
ಅದೇ ಥಿಯರಿ ಪಾರ್ಟಿಗೆ ನಾನೇ ಕೊಟ್ಟಿನಿ ಆನ್ಸರ್ಸ್. You solve the
ಓಕೆ ಮ್ಯಾಮ್.
problems. Okay.
ಓಕೆ
So the
ಓಕೆ
material entirely I cannot upload in the Google Classroom. Entire notes. So I need to convert that into PDF. So time being for the internals, I have given the material related to the theory part, theory questions. So problems what I have solved in the regular class, from those only I have given the problems there. So solve it and submit the assignment for the date what I have specified. Is it clear?
ಓಕೆ ಮ್ಯಾಮ್.
Okay. So anyone can come and get it xerox the textbook their material. So later you can forward that to your classmates. And shortly you people will be coming next week I think offline. So you can get it xerox the material rather than having a soft copy. Fine? Okay, I'll leave the class now. It's already time. Why the strength is so less now?